In order for the index laws to work, we must have the same bases. The first index law is the addition law. If I'm multiplying two numbers of the same base, then I simply have to add the powers. Simplify the following expressions. The first thing we also need to make sure we do is we get our numbers into simplest index form. And what does that mean? That means that we need to identify the prime factors and get them in power form. So when you're solving indices with numbers, may I suggest not wasting your time doing very big multiplication, such as 16 times 32. Because in this topic we don't particularly want to use calculators, it would be a waste of your time to do this by hand. We would much rather you express these as indices. For instance, 16 is the same as saying 2 times 2 is 4, times 2 is 8, times 2 is 16. Therefore, that's 2 to the power of 4. Times by 32, which is 2 to the power of 5, gets me 2 to the power of 9. If, however, the number is fairly small, such as 3 times 6, then yes, you can either write it as 3 squared times 2, or you can alternatively just write it as 18. That is also fine. A, 4nq squared times 2q cubed. It's very hard to say if you're about to sneeze. One of my strategies for this would be to use some different colors and to multiply each component at a time. Start with the numbers, then start with each of the same letters. We have a 4 and we have a 2 here. This 4 is the same as saying 2 squared, because 2 times 2 is 4, times another 2. Then we have this n. There's no other n's, so that n can stay there. And then we've got this q squared and this q cubed. So my final answer will involve 2 to the power of 2 plus, now if there's no power on there, we will assume there is a 1. There is 1n, and there is 2 plus 3 q's. So our answer is 2 cubed n q to the power of 5. If you had decided to do 4 times 2, which is 8 nq to the power of 5, that is also perfectly fine. These sorts of questions in an assessment would only be worth 1 mark. So if you can reach to the answer correctly, you would get 1 mark. So I've got 3. 9 is the same as 3 squared. 81 is equal to 3 to the power of 4. Now, how did I know that? Well, I know that 81 is the same as saying 9 times 9, or 9 squared. And 9s are the same as saying 3 squared times 3 squared. So therefore, that's 3 to the power of 4. Then I have x times x times x squared. Then I have p times p cubed times p to the power of 4. So my answer here would be 3 to the power of 1 plus 2 plus 4. X to the power of, remember those will have 1s in there, 1 plus 1 plus 2. P, 1 plus 3 plus 4, which gets me 3 to the power of 7. X to the power of 4. And P to the power of 8. C, 25h cubed g squared pz times zp squared times 25hgz to the power of 4. Start with the numbers. So 25 and 25 will be 5 squared times 5 squared. So that's going to be 5 squared plus another 5. So we've got 5 squared times 5 squared, or 5 to the power of 2 plus 2. We've got an h cubed and one more h. So that's h to the power of 3 plus 1. We've got a g squared and another g. So that's the g to the power of 2 plus 1. We have a p here and a p squared. We have a z, another z, and 4 more z's. So our final answer is 5 to the power of 4, h to the power of 4, g to the power of 3, p to the power of 3, and z to the power of 6.